This is lesson 86, VHDL example 57. And in this example, we're going to write a VHDL program that will shift data into the shift register. Now, we're going to do a little trick here. We're going to use button 0 and button 1 to shift either a 0 or a 1 into this shift register. We're going to use clock div and clock pulse that we've seen before. And look at this OR gate. We're going to OR button 0 and button 1, which means button 0, 1 will go high if you press either button 0 or button 1. And when button 0, 1 goes high, you'll get a little delayed clock pulse out, single clock pulse that will debounce these buttons. So you're going to get a clock pulse if you press button 0 or button 1. We'll bring button 1 into D in. We'll shift in through Q0, this time in the least significant bit, and then we're going to display the output of the shift register on the 8 LEDs. So if you press button 0, you'll get a clock pulse here which will shift everything in, but since button 1 is 0, you'll shift in a 0. On the other hand, if you press button 1, you'll also get a clock pulse. Remember, it's delayed a little bit, so by the time the clock pulse comes, the rising edge of the clock, this button will be pressed down, and so you'll have a D in of 1. So you'll shift in a 1. So if you press button 1, you shift in a 1. You press button 0, you shift in a 0. So let's write this shift reg 8. It's very similar to the shift register that we've seen before. Here D in will just bring in the least significant bit of Q. So we'll make a signal QS, and we have a process clock and clear. If clear equals 1, we'll set QS to 0. Else on the rising edge of the clock, D in gets shifted into QS0, and then QS7 down to 1 gets QS6 down to 0. So QS0 goes to QS1, and so forth. QS6 will go into QS7. Remember, QS has to be a signal because we want this QS0 that gets shifted into here not to be this QS0, which gets set to D in, but rather the original QS0 that we have when we started the process. Remember, signals don't get evaluated until the end of the process. Then we'll set Q to QS at the end. Okay, well, let's just write our top level design. The inputs will be M clock, button 3 down to 0, and the LDs 7 down to 0. Here's our component declaration for clock div, our component declaration for clock pulse, and our component declaration for shift reg 8. We'll have signals clear, clock 180, clock pulse, and button 01. Then we'll set clear to button 3. Button 01, you remember, is just button 0 ORed with button 1. And then we have the port map for clock div, bringing out the clock 190. We have the port map for clock pulse, in which case the input is button 01, you remember, and the output is clock P. And then we have the port map for shift reg 8. The D in is button 1, and the clock P is the clock input, and the Qs will get displayed on the LEDs. So here's a simulation. Now this is just a simulation of the module, the shift reg 8 one. So here is D in. We show D in as sort of 1, 1, and then off for a couple, up for 1. And you'll see it gets shifted into Q0, and then that 2 pulse will get shifted over to Q1, Q2, Q3, 4, 5, 6, 7. So in the top level design, these would be connected to the LEDs, and you'd watch the LEDs lights shift through. So you should download this top level design into your FPGA board, and when you press button 0, nothing should happen. When you press button 1, you should get a the rightmost LED, LD0, will light up, and then as you press button 0 and button 1, say alternately, you'll see these ones shift through the LEDs. So you can check out this on your own FPGA board.